Let's get moving. And I basically completed this whole problem for us. So we can just kind of check our work. I do need to plug this into the calculator still. Again, dropping that line down in the middle to make this two right triangles is really important. Otherwise, we'd have to use completely different theorems and formulas to come up with these values to find the side lengths. And there are formulas and theorems that apply to non-right triangles. I don't know for sure if we'll get to those or not in this class. That's more like review from geometry. So I'm referring to like law of sines, law of cosines, probably something you did back in geometry. Those can be applied to non-right triangles. Okay, but when we're in right triangles, we can use SOHCAHTOA and or the Pythagorean theorem. Okay, Pythagorean theorem here does not matter. Um, just using SOHCAHTOA is how we're going to be able to find this value. Okay, so with these angles being the base angles and isosceles, remember that means that two side lengths are the same, which means two angles are also the same. Okay, so that's what these lines are for, just noting that these lengths are the exact same. Same with those angles. And then we're trying to find the leg length, okay, that are equal here. So I'm trying to find that x. By us dropping this line down the middle, we can assume that that is halfway. So that makes this smaller leg 5 centimeters, and we're actually trying to find the hypotenuse here. Telling me to use cosine, since we know the adjacent side and we're looking for the hypotenuse. Okay, so this is how we would set that up. To solve it, I'd multiply both sides by x, and then divide by cosine of 31. And after I plug that in the calculator, 5 divided by, I'm going to make sure that I am degree mode, which I am, so 5 divided by cosine of 31 gives me a leg length of 5.8 centimeters. Okay, and that would be the length of both of these, 5.8 centimeters. Okay, all good there? Awesome. All right, well, let's go through. We're going to do a few applications, and then I'm going to give you some time to work on some of the Math Excel while I start to meet with some of you. But before we actually jump straight into the applications, some vocab that's really important with these. So we have an angle of elevation and angle of depression, and these are both really important. So when we're talking about like angles, know that there will always be an imaginary horizontal line where that angle is formed. Okay, now that part's really important because a lot of times with how angles can be measured, they're not always measured from the ground. Sometimes they might be measured with a device, so looking or starting from that kind of eyesight. Okay, so what we're going to add in is whenever we're looking up, this is the angle of elevation. So that's us looking up. And then the opposite is, let's say we were trying to find the angle from the cloud down to the eyesight here. This would be the angle of depression. Which is us looking down. So elevation up, depression down. And let's just add in, like this is kind of an imaginary horizontal. It's not always going to be imaginary, it just kind of depends on the context of the problem. So I would draw all that in. Yeah, Monty, go ahead. On the side of this is just a reminder about how we find angles. So in this case, when we're looking for an angle, we're going to have to use, these are the inverse trig functions. And I think we had some questions about this last time. And knowing that these are these are different than the reciprocal functions, okay? The inverse cosine, inverse sine, inverse tangent, they are not the reciprocal functions. They are very different, okay? So just kind of let's do one example here. If I have sine of theta, and we know that it's equal to the opposite side over the hypotenuse side, well, if I want to solve for theta, we need a way to undo taking the sine of that angle theta. So this also is a good reminder that you take trig functions of angles. So sine of an angle, cosine of an angle, tangent of an angle. Okay, so if I want to solve for the angle, I need to undo taking the sine, and that happens by us taking the inverse sine, which I would do to both sides. And the inverse sine gets rid of us taking the sine, and thus the angle is equal to the inverse sine of the ratio of side lengths. Okay, and a really important distinction, and that's what I mean about being conceptual, right? Almost every lesson this semester, I've kind of mentioned something about thinking about this more conceptually. Here we want to remember that we take trig functions of angles. Inverse trig functions help us find that angle. Everyone following with me there? Okay. And we will have to use the calculator to find that value. Okay, so let's do, we'll go through a couple of these applications. Those of you that have completed the Math Excel that's due tonight, you've probably already worked through these, which is great. If you haven't, you're going to get some time to do that shortly. All right, so it says the plane ascends with an angle of elevation of 15 degrees. What will the plane's horizontal distance from the runway when it reaches its target elevation of 30,000 feet? A lot of times we'll have to draw the picture completely. With this giving us a triangle, we can at least start to kind of figure out what is this entirely saying. So we'll draw our little airplane down here. I'm not a good drawer. I'm not going to even try. So we'll just call this the airplane right here. So the airplane takes off. It takes off at an angle of elevation, so meaning it's going up at 15 degrees. The horizontal distance from the runway, so we'll call this the end of the runway right here. And this is its horizontal distance. And I would, when working with these, being specific with the drawing and labeling really helps us figure out what we're solving for and then what trig function we're going to need to do that. Okay, so we're trying to figure out the horizontal distance, so this leg here, when it reaches its target elevation of 30,000 feet. Well, elevation is going to be that vertical distance. So this plane has now traveled 30,000 feet up. I don't know why I put parentheses there. And so the one thing that we need to decide is based on the information provided, which trig function is going to be best to use. Well, I don't know anything about the hypotenuse here. And when I'm looking at this, I don't even need to find the hypotenuse. So I'm thinking about which trig function does not include the hypotenuse. That would be tangent. Okay. You will never use the reciprocal functions. You can, it just makes it a heck of a lot messier. And to plug things in on the calculator, remember there's not really a reciprocal function button. So when we're trying to find angles and side lengths, think of the original trig functions. Okay, so I'm going to use tangent of the angle, and that's why I really emphasize at the beginning that we take trig functions of angles, okay, knowing that we actually need to take tangent of 15 degrees, which is then equal to the opposite side, that 30,000 feet, over the adjacent side, which we don't know. So I'm going to call that x. And now the solving of this is just like the warm-up. I'll multiply by x, so x tangent of 15 degrees equals 30,000. Then divide by tangent of 15. And that'll give us the horizontal distance. So 30,000, I should also just, again, double check that my calculator is in degree mode. Okay, which it is. Always a good habit to check that before you start plugging things into the calculator. So 30,000 divided by tangent of 15 is, what is that, 111,961.5 feet. And while we're at it, let's just do a unit conversion. I don't think we'll have to do this on Math Excel, but this is just a good reminder as to how we did those unit conversions. Remember, we did that with like the rotational amounts, right? The angular speed and linear speed. So let's try to figure out how many miles is this. So we're going to take the amount of feet, 11,961.5 feet, and we're going to try to convert this into miles, so just doing unit conversions. Now remember, when we're trying to convert this, we need the feet to divide out. So I'm going to put what I know about feet, and I'm thinking about, okay, feet, and I want to convert this into miles. So my top unit is going to be in miles. I'm like, okay, 1 mile is equal to 5,280 feet, right? 5280? Yeah, that's right. That's right. So I just need to divide it. So I'll just take that number, which is already in my calculator, so I can just divide by 5280, and it's about 21.2 miles. That was extra. But again, good practice for us to think about those units and how we can kind of do those unit conversions. All right, questions here? All right, let's keep moving. Okay. Okay. The swimming pool is 30 meters long. The bottom of the pool is slanted so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. Find the angle of depression of the bottom of the pool. Let's again start to kind of label this and think about what do we know here. So we know that we have a pool that is 30 meters long. We know that, so the water depth, okay, so this almost feels like we need to create two triangles, right? Because we have two different depths here. So it's almost like we have this one triangle to kind of start. This would be the shallow end. Then we dip down a little bit further and end up with the deep end. Okay, or at least that's kind of what I'm gathering from what this is saying here. These are two right triangles. Right, yeah, it's almost kind of the, what you're saying, flip this one? Okay, so flip this. Okay. Yeah, yeah, I see what you're saying. So more like we got the water level. Straight down. Ah, why am I having a hard time visualizing this? Yeah. Oh. There we go. So like sorry for people watching the video. Struggling a little bit today with my math, but we're ready to go now. So based on what this information provided, we gathered that the water level started at 1.3 meters, dropped down to 4 meters. So we're trying to find the angle of depression, which is this angle right here. Now, since we know that the water level went from 1.3 to 4, we have this leg length of 2.7. The horizontal length is 30 meters. And so now we just need to find that angle. Now, again, we're going to start with the trig function that uses the information provided. I know 2 legs. If I want to find the hypotenuse, we can, but we don't need to. Okay, that would just be extra work. So again, I'm thinking about I have this angle, which trig function does not involve the hypotenuse. That would be tangent. So I'm going to take tangent of the angle x, and it's equal to the opposite side, which is 2.7, over the adjacent side of 30. And if I want to find the angle, I have to undo taking the tangent of that angle and take the inverse tangent of 2.7 divided by 30. And in this case, we do want to make sure we're in degree mode. That way the angle is given back to us in degrees, which I've been using the same calculator. I already know that I'm in degree mode. And so I get about 5 degrees is the angle of depression there. Okay, well, most of the time with the angles, you round to the nearest degree. Okay. Not too bad. As long as we know how to draw the picture, which Apparently you all did. I did not. All right, real quick, why don't we have you do one last example just in your groups or on your own? And then this is where we'll take our break and I'll start meeting with some of you about course selection for next year. So it says a surveyor measured the angle of elevation to be 22 degrees to the top of the building. A transit is 5 feet above the ground and 300 feet from the building. Find the building's height. Draw a picture. See what you come up with. Um, Here's your work for this last problem. Okay, let me get voices to stop real quick. So I think this is another good example where drawing the picture can help because, again, when we're measuring angles out in the real world, they're typically measured with devices. I think the two names I can think of off the top of my head are called a sextant and a transit. So a transit is basically like a tripod. So you would put that on the ground and then you can measure the angle. So that's what this kind of stick figure looking thing is me drawing that transit. And I know that's 5 feet off the ground. So then this horizontal line, that's what I was talking about when I first introduced the angle of elevation and depression. That horizontal line is really important because that's where the angle is formed. It's not the angle from the ground looking straight up to the top of the building, just from the angle of that goes parallel to the ground where that transit is. Okay, so that's our angle. When I find the value of x, that's not the full height of the building. We have to add that extra 5 feet that the transit is off the ground. Okay, so again, we don't need to do anything with the hypotenuse. So I'm going to use tangent of the angle. And then to get x by itself, and multiply both sides by 300, get 121.2 feet. That is the bulk of the height of the building. We still have to add in that extra 5 feet to get the full height from there. All right. Okay, any questions here? Okay, we're going to stop there for